Good cup of tea and coffee. So coming on to the session 2 of today, it's in the polymer industry. Now, starting with Mr. Ramkumar, so he's gonna give us a glimpse about the robotics and robots and automation in the injection molding. And one gentleman once told me that robots are the future because robots would never get drunk, robots would never ask you for more money, never ask you for more leaves. So, and we would look forward to Mr. Ramkumar to put more deeper vision into robots, how are they gonna work. So, Mr. Ramkumar, a technical marketing expert in injection molding industry, obtained master's degree in marketing and handled various profiles in the injection molding field. Having 19 years of rich experience in multinational corporates in the field of plastics engineering, technology, automations with robots, bowl feeders, vision systems, etc. in injection molding and auxiliaries especially. So working for Wittmann, Battenfeld, India for past 14 years, heading Southern region for sales and marketing. So that's Mr. Ramkumar. And along with him in our session is Mr. Wilman Zhou. So he's again here for some advanced things to talk about injection molding. As we all know that injection molding in a polymer industry has been playing a very vital role all the time, and advancements have been going on and on in the injection molding every year. And with so-called Industry 4.0 and all the digitalizations coming in, so we look forward to Mr. Wilman Zhou to put more light on those aspects. So Mr. Wilman Zhou with the master's degree in supply chain management at University of Sussex, United Kingdom, 8 years of working experience in plastic machinery industry, regional sales manager, Asia Pacific for Yizumi Precision Machines Pvt Ltd. So Yizumi, as you know, has been quite good into innovations and putting a lot of money into R&D. So we are looking forward to Mr. Zhou for more aspects about advancements in injection molding. So now I invite Mr. Ramkumar to please come on the dais and start the session.
Hello. Thanks for the nice introduction. I would like to thank our management who gave the opportunity to present or discuss about the injection molding, plastic injection molding auxiliaries and machineries in this prestigious forum. So we are going to discuss about what is the contribution of robot automation in injection molding machine. So who are we? Wittmann is a leading manufacturer of injection molding machines and robotics and auxiliaries for plastic processors. So we have got 9 manufacturing facilities worldwide, and our sales and service network presented in 68 countries. So what we do? We provide one-stop solution to plastic injection molding processors, right from silos to part pickers. So we provide silos, raw material silos, then we provide material drying, we provide material blending and loading, conveying of the materials to respective machines. And we took over Battenfeld injection molding technology in 2008. So now we could able to provide a complete solution for injection molding processor. And we have got robotics, can handle the part picking and as well as insert placing applications. Then the same robot we are taking into next level of automation by backing it of your plastic parts. And what market trend in every product? And less application, and it was too much expensive to purchase even. But in the today's condition, everything is became handy, and you want the data every day. And what is going to be the future in the plastic industry? Not even in the plastic industry, in all the products. So everything gets smaller, more functions in less space, then weight reduction, smaller dimensions, low energy consumption, and new product design. And end of the day, you are going to take the data from there and you are going to store it into the cloud. So what does the market? End of the day, what your OEM requirement in the plastic industry? They need higher quality, increase of productivity, they want zero defect, they want to achieve all their vendors to achieve zero defect, and they wanted to have their product to extended flexibility when there is a future requirement to be handled by the same product, same equipment, and then running the machines round the clock, plan for the increased cavity, plan for second mold, compromise on quality measures sometime. Why not automation? The general perception in the industry is that automation is becoming costly and it is going to be a bigger cost, but it is not so. That is what we are here now. Why robot automation in the injection molding industry? Shorter takeout time, integrate all your downstream and upstream tasks, automated insert positioning, insert placing, then increased utilization of your machines, reducing the handling rejections, bringing up the consistency of the machines, optimize the material flow, and integrated quality control system by having the vision sensing, weight, online weight monitoring. Then we can also extend the robot to next level of automation of doing packing of your products. So where is Wittmann in this industry? Wittmann is the first ever robot to get such a Red Dot Design Award by its design and stability. It has well proven modular concept, stable design, best balancing through special arrangement of linear bearings, and our robots are having highest lifetime and superior quality by using best components from the market. So this is our mechanical advantage. We provide flexible x-axis to avoid the cantilever, and we provide heavy duty linear bearings by which we commit our customer saying that 500 kilometers of running without any lubrication. So thanks to our linear bearing design. And there are many technologies in Wittmann robots. We have got only very short time of 20-25 minutes. So I am going to cover some of the advantages what we carry, which is going to benefit for the injection molding processors. So I am going to take you some of the advantages, which is smart removal, mold open synchronization, programmable safety areas, and intelligent vacuum, and quick edit, smart start. And the next level is your network possibilities. So one by one we will go. Smart removal. What is smart removal? Normally, robo has to go a simple L operation to take out the part from the molding machine. But whereas by the smart removal, you can all our three servo motors like X, Y, Z will be simultaneously operating, and it will go together, it will run together to take out the part in a shortest takeout time. So where you can save close to 15 to 20% of your takeout time. Normally, your takeout time is close to 2 seconds, means you can save close to 30%, which is 1.4 seconds. 0.6 seconds you can close by having this smart removal function. And mold open synchronization. This is standard in our injection molding machine. It is also available as an option to other brands of injection molding machines. And there is a options called smart vacuum. In today's condition, I have seen some of the machines are running, like when you set the mold open of 450 mm or 500 mm, it stops at 451 or 449. It is not stopping end of the like 450 in the accuracy. So we have got the function called follow mold. What it does, when you enable this follow mold, it goes to the product and it finds the products and picks up. So by which you will be saving the time. So programmable safety areas. In today's condition, like everyone would be having an external fencing to safeguard their manpower for any accidents. But whereas in the software itself, we have given the programmable safety areas where you can save, you can create your own safety areas. So if the manpower wants to take the robot in that area, it won't allow him to do that. So by which you can reduce all the accidents in our robots. So it will be privilege for all like you owners that you will be giving 200% importance to the safety, so that your operator will be utilizing our robots 100% without any fear. That is what happening. So intelligent vacuum. All these days, the vacuum monitoring is being controlled by or monitored by digital vacuum circuit. But whereas Wittmann has integrated these digital vacuum circuits to our teach box in our controllers, by which what you can do exactly is you can set the pressure or monitoring the pressure, measure the pressure, and also you can control the vacuum pressure. As you know, everyone, the vacuum is getting generated through Venturi principle by external compressed air. So when you don't require that much compressed air to generate the vacuum, so your power consumption will be reduced. Quick edit. After COVID like pandemic, everyone says we are not getting the skilled manpower to teach or program the robot. So we came up with a new solution to those customers, that quick edit, which is very easy to operate, and there is no programming skills are required to teach the robot. So what you are going to do is that there is one menu, quick edit menu. You have to follow 8 simple steps by entering your value, where you can generate your own logic, where you can generate your own teach program for the particular part. This is the slide. You can see 1, 2, 3, 4, 5, 6 is there. So by 8 steps, you can create your own teach program. Smart start. Like injection molding machine, like dry cycle, the similar way we do also have a dry cycle mode. Normally we do have a virtual subpendant and also a foil button subpendant. If there any issue in the foil button, like Apple phone, you will be having icons in the screen. The same icons can be used for like the functions whatever you wanted to do. The similar way in the screen, in our controller, you will be having similar kind of icons. So if there any issues in the foil button, by which icons you can do whatever the requirements you needed, like taking the robot into the home position, or putting into manual, putting into automatic mode, everything you can do. And when you wanted to try, do the dry cycle mode, you have to satisfy some of the requirements, like where is the machine is going to be, like it is on open position or closed position, and where is the ejector, and you have to wait for the vacuum and vacuum monitoring, by which you can do the dry cycle mode. You can start the dry cycle mode with anti-collision detection. So there won't be any damage to your mold and as well as the part. The last one is important one. During COVID, everyone wanted to have the service, but end of the day, we could not able to go out due to many problems. So we connected all our robots in hotline. So we have given the support to online to our customer. All that you have to provide at one static IP, so that we will take your controller into our network, and whatever the basic needs you wanted, like editing the program, modifying the program, or is there any issue that we can correct from our sitting in our offices. In nowadays, all our customers are having more than 3 to 4 plants. They wanted to access their plant or monitor their plant by sitting in their city offices. So the demand is rising currently. So we have implemented this new network parts possibilities to take all the teach programs, system report, error buffer, and command buffer. And everyone knows about VNC, virtual network computing. So virtual network computing, if you buy the virtual network computing, you can do the online editing, offline editing through sitting in your office, teaching the program from your office. Even we can take your controller. Then this is our teach box. And it is a high performance IPC for more dynamic movements for the robots and improved software functions and features what we have seen now. So Wittmann is the only company who is giving detachable controller, whereas everyone is giving attachable controller, all their RAMs inside the controller, so they could not able to detach from the machine. But whereas our robot, you can detach it and you keep it in your maintenance room if there are any issues. And also to avoid misusage, you can take out this screen, the teach box. The teach box is required only when you modify or edit the existing program or create the new program, you need this teach box. Otherwise, you no need to have this teach box. If you are having more than 10 robots from Wittmann, you can buy only two controllers by which you can run all your 10 robots. All that we have got a subpendant. This is a subpendant. And what are the basic function, like when the power goes and comes, the robot, you wanted to interface, you wanted to take the robot into the home position, teaching the robot, everything can be done through this one. Only when you want to edit or create a new program, you need this controller. And we can store close to 50 or 100 programs in our internal memory itself. If you want to save more programs in our in our RAM, you can always have a USB connection. You can put your USB stick and you can take the robot program and whatever you want. So we have seen the features and functions and advantages and only Wittmann unique features. So now I really want to take you into implementing the robot and what is the cycle time you are going to save on that. I am going to show you two molds. One is running at 40 seconds, another one is running at 15 seconds. See, all these days we have been reducing the cycle time only by implementing the robot, not touching your quality parameters, which is affecting your part quality, like your processing parameters like injection, cooling, holding, that we never touch. We touch only the other areas. What are those? Here you can see the injection and cooling is 40 and the mold open is 1.2. After implementing it became 0.8 and gate open is 1. We reduced it to 0 since you are implementing the robo, and take out time was 2 by the manpower. After implementing it became 1, and gate close and restart it was 1.5. Again it is not needed since you are implemented the robo. Mold close is again 0.8. So total cycle time 40.9 versus 48.9 versus 42.6. It is close to 9.2 percentage savings. In a shorter cycle time, you can save close to 19.6 seconds. Similar way, we are just reducing the cycle time on gate open and close and take out time, not touching your injection parameters, which affects to your product quality. And how do you make money with the robots? If you save 0.3 seconds in a 12.5 second cycle time, where you can yield close to 62,000 additional cycles, and if it is a 4 cavity mold, it is close to 248,000 extra parts what you can generate through implementing the robot. I don't think so you will be adding a machine instead of going and saving through robots. So there is one more classic ROI which we have calculated, or which we have given to one of the insert molding application requirement. We studied this part at customer place. It was running at 58. Then we, after implementing the robot, we saved close to 13 seconds. We could able to take 9,486 parts, since it is a 8 cavity mold. When you convert into the number of shifts, it's close to 19 shifts. We could able to reduce 52,000 on that. Then we could able to save 0.5 manpower, since they do have some more requirements to be seen in the part quality. So they had one manpower can manage 2 machines. So we could able to reduce 0.5 manpower, then by which we reduced 19,500. So finally we could able to reduce 80,000 odd rupees in this one application. End of the day, our robot is close to 10 lakhs. They could able to take the ROI in 1 year, which is a very good one. Normally ROI close to be 2 years is okay, but we are giving less than 1 year. So one more case study we did at front bumper, where it was running at 76. After implementing the robo, it became 52, and they could able to take additional parts and additional savings. Our saving is 276, and when you convert into shift, it is close to 35 shifts. Based on the industry standard, I took 1,625 rupees for each shift. It is close to 4.4 lakhs. Again, in the manpower, 39,000. So finally, they could able to take the ROI in 8 months. So this is the cycle time breakup. So again, we are not going to touch this injection, cooling, holding parameters. So mold open seconds are same, 9 and 9. And gate open was 8, and it has been brought to 0. Then take out time was 21. Since it is a very big machine, 2,800 ton machine, so operator goes inside and taking out the part out. So it took almost 21 seconds, which is average. Normally they used to take more than that also. But after implementing the robot, it became 7. Then gate close and restart, it was 2. Then we brought to 0. Mold close was 8, and similar way, mold close the same opening only we are using for the robot. So here we could able to reduce 32%. Smart removal parallelly robot comes into action. This is the smart vacuum. This goes towards the mold and picks the part. Eco mode. Robo has to be faster only on mold area. Other areas it can match your own cycle time, 40 or 60, whatever, where you can save all mechanical parts, life, and also energy. You can see eco mode energy and versus no eco mode energy. This is one of the application. One of the function we have soft torque. When someone sets like excess ejector load, ejector stroke also, robot will come and bang your mold. By that time, your robot and as well as your robotic arm and mold will be damaged. To safeguard that, what we are doing is we are measuring the torque on the x-axis. If you are exceeding the torque, then we are releasing the brake of the x-axis. So by which you are safeguarding your robot and as well as the mold. This is the sensitivity. So ejector can push our x-axis back to safeguard your robot. So finally, why Wittmann? So we never recommend or suggest to our customer not to go for any pneumatic robots where you are indirectly consuming the power by adding your compressor capacity. But Wittmann has only servo robots. We don't give or we don't have any hybrid robots where every customer, every other brands are having this kind of pneumatic and servo axis. And we are the only company is giving rack and pinion mechanism in the x-axis. Because we have got a robot where in future you can go for a insert placing application, the same robot can be adapted. An eco mode operation you have seen, an ergonomic design, and we are using IE 5 series super premium energy efficient servo motors where your energy consumption will be very less, and recycling the brake energy. And we have installed more than 5,000 robots in 15 years time. So we have got a very much knowledgeable team in India, and our strength is our EOIT manufacturing unit in India where we can make all complex insert molding application, design and manufacturing, assembly and testing, as well as install to our customers. This is one more new installation which you have done. The challenging insert placing automation. This is the part which has 9 inserts to be fixed on fixed side and 2 numbers on moving side, the 2 on side course. So the part name is shroud. So this is the EOIT concept. So we have got 2 portions. One is for part pickup, another one is for insert pickup, and there is an insert holding table where you can have operator would be manually placing the inserts. Then he confirms the robot. Then robot comes down and picks the inserts, and as well as goes inside the machine and takes out part. I will show you this video after this one. So what project benefit to the customer is going to be like 100% okay, there is no insert missing complaint from the customer. So ROI is less than 10 months again, insert placing and part takeout time reduced, and this is a challenging insert molding application. Everyone denied and Wittmann only took this project and succeeded. So there are many insert molding applications we have given in last 15 years. This is for like gear components and seat adjustment rods. We have given for dedicating application to dashboards. Then we have given for insert placing application to rear light housings. Then like flaming of front grill also we have done. Before painting, before plating, you need to have a smooth surface. And there are some success stories, mean to say we have installed so many robots. So I wanted to share you some of the installation references. So here we have given, we can provide a complete drying and conveying system with robo as well as MTC and chillers. And this is one of our key customer in Chennai where they are having more than 60 plus robots. And there is one more good video, like in this year recently we have installed many challenging applications that I wanted to show to you. Sir, on the video. So this is pick and place application, taking out the rear light headlamp. Placing application which I have shown the concept. After inserting, operator gives a confirmation to the robot. So robot comes down and picks the part, picks the inserts on the insert holding table, then goes inside the machine, placing the inserts on the side core and pick up the part and placing the inserts on the cavity side of the mold. Again is giving the part to the one more C-axis which is mounted on the conveyor. So beyond pick and place, we have been doing many applications like cavity separations, one of the application where customer wanted to have the cavity separation. If there is problem in one cavity, even customer can avoid that one cavity sending to customer, and he can always having other cavities to send to customer if there are any quality complaints. An online decatting we are doing. So after decatting, we can place part one side and runner we can keep it in another bin. An online assembly also we can do. We are also providing IML system for paint pails and lubrication industries as well as ice cream containers, packaging applications. We provide top entry and side entry robots to their requirements. You can see the WIP that is getting generated. So please let us know your requirements. We will come and visit your facility, and we will throw wherever the possibility of automation which can save your cost. So once again, thank to IPI, and thanks for your valuable time.
Thank you so much, Mr. Ramkumar, for telling us about the new age auxiliaries for the injection molding machines. Now we would like to hear from Mr. Zhou for the new age technologies in injection molding.
Hello, good morning everyone, and thanks for your coming for today's presentation. Before my presentation, I would like to thank IPI to create such great event for us to gathering here to share our thoughts and our technology. And my name is Wilman Zhou from Yizumi HPM, and I'm the sales regional manager for South Pacific area. Today I'm going to share with you the Yizumi HPM experience in the advanced plastic molding technology. And I'm going to divide my presentation into 4 parts. Firstly, I will a little bit introduce about Yizumi HPM, and then I will go through the second part of the water injection technology, and the next one is about our 3D printing space age machinery, and the last one is talking about the direct compounding injection molding design system that researched and developed by Yizumi HPM and also our Germany R&D Center. And if you have any question about my PPT that you may have, I would like to appreciate you mark down and share with me during the question and answering stage. Here, I will briefly introduce about Yizumi and the global operation. As you can see from the map, Yizumi have a service center and all around the world, including the China, USA, Germany, and also Brazil and Thailand. We have over 40 service and technical service agents all around the world, and also have the covering more than 70 countries and regions around the world. And Yizumi has already established the production base in China and India and USA. And the production base is more than around 600,000 square meters totally. And we have over 3,000 employees all around the world. Next, I'm going to introduce about our Yizumi India factory. And this is our first factory in Ahmedabad, which is operating in 2017. This factory occupies an area around 8,700 square meters. The design annual production capacity is around 300 sets per year. In 2021, last year, and our machine manufactured by our Indian factory is around 500 sets. And the sales turnover last year is around 150 crores. And the year increase in last year is about the sales turnover is around 100% increase. As you can see, our production capacity is far below our sales demand from the market. That's why in this year, we are going to have a new plant in Ahmedabad. This new plant is covering area about 81,000 square meters. And this new plant enables Yizumi to boost up our production capacity to meet the market demand. For this new factory, we are going to operate it in next month, 7th of October. For this opportunity, I would like to invite you to come to our plant. We will be very felicitated to having you in our inauguration in next month. This plant with design production capacity is around 1,000 sets per year. And the production capacity of injection molding machine range from 6 tonnage to 3,200 tonnage, that we can make bigger tonnage machine in our new factory. And the machine model is not only covering the normal standard toggle machine, but also two-pattern machine and also the high-speed packaging machine and also full electric machines. And this is our sales network all around the countries in India, and it's covering from the north to the south and east to the west. And also in the middle, we already cover all around India. And this is our production team in India, in Ahmedabad. Currently, we have around 120 people in our team for production. And this is our service team all across India. We have around 20 service team members across India. And we also have a Chennai Tech Center near here. And we have stock machine there and also spare parts to serve our customer all across the southern India. And also our Yizumi commitment and standard service response time is 4 hours when we receive customer feedback or service response requests. And what is our Yizumi strategic goal for customer? We always stand with our customer and focus on product itself to provide a very integrative, customized turnkey solution, not only based on the machine. We develop the turnkey solution based on the customer's product, and also from the product to the mold, the machine, and the auxiliaries, like the robot and hopper dryer, and also the auxiliaries around the machine, and also the production environment, like the Industry 4.0, the EMS system, or we also call MAX system. Next one, I'm going to show you a video that Yizumi recently have a great achievement for the huge machine, giant machine of 8,500 tonnage. This is for the product for the logistic park. The short weight of this machine can reach 140 kilograms, and the pattern size is around 4 meters. The tie bar distance is nearly 3.5 tie bar distance. And this machine with 2 injection, parallel injection, you can see there's 2 holes on the pattern. And we built up this machine in 4 months. And this machine is about to deliver from the factory in China. This machine is not only big and heavy, we also combine the technology about how to control the pattern size, the movement with precision, more precision, and also the coordination with 2 injection units to inject to the mold size more coordinatedly. Next one, I'm going to go for the topic about the advanced molding process for the water injection technology. When we talk about water injection technology and also gas injection technology, what is the difference from this water injection or gas injection compared to the general injection? First of all, it's really similar. The only difference is the water injection shoot inside the mold with 70 to 80% of the mold volume, and then the water or the gas injection will push the water or the gas inside the mold. When the melted plastic in contact with the mold wall, it will be solid. Then the water and the gas will push the material to full one in the mold cavities and make the product more solid than the normal injection. And you can place the video in the PPT. There's a click, and you will see how it works compared to the normal one. Okay. And the advantage of water injection technology related to the regular injection molding, there's significant reduction of cycle time because the water injected into the mold and also the product inside the product with really better cooling effects, because the water injected into the mold with around 10 to 80 temperature. And also there's a benefit with the reduction of material use because of the bigger cavities and with a hollow structure inside the product. And the third is the animation of the consistent shrinkage and also low wrapping, because the water inject inside the product with really high pressure, is around 30 bar. Because of the high pressure water injection, the reduction of sink marks and weld lines on the product surface, it makes the product with better surface outlook. And also the reduction of mold, the clamping force on the injection molding machine, because there are some, the product inside have a high pressure to push the material during the holding stage. Okay, compared to the water injection technology to the gas injection technology, what is the advantage? First of all, the water injection with a better cooling effect and a shortest production cycle time than the gas. And the second one is the water is almost everywhere. You can find the water much easier and cheaper than the nitrogen and also the aerosol. And you can see from the 3 circles from the left side, it is the research from IKV Institute in Germany. The water cooling time, it takes around 90 seconds. Is compared to the aerosol is 150 second cooling time, and for the gas is around 300 second cooling time. There is really obvious advantage from the cooling injection technology. And also water injection technology is with better control process, because the water compared to the gas is nearly impressible. Design or product design to have a free design advantage. And also it can achieve more uniform and thinner wall thickness. And here is the example that we have done for the water injection technology. You can see from this part, this white part is for the wheel. And the material come from the right hand side for the melted plastic to go inside to the mold. And also then the water will come from the strategic water inlet path to push the material to the side cavities. I will show you the video about how it works about this product. And for the right hand side is animation about when the material injected into the mold, around 80% of the mold volume, and then the water will push back the material backflow to the barrel. Then next shot, the material will come out from the barrel. And this is another type of water injection with projectile. Then with projectile, you can have a thinner wall and more uniform inside the tube. It's really frequently used for the auto part cooling line for the engine. And now I will show you the actual production or reference from Yizumi. Could you place the video? This is the wheel for the car, and there's two material, and this is with water injection without projectile. This is piggyback injection molding machine, and first they will inject the core part with PP material and glass fiber 50% from the smaller injection unit. Then here they will place the core part of the You see the material go from the right hand side, and also the water go from right hand side and push the material back to the side cavities. And for the water injection technology, and you may have a question if I want to build up such technology for your product, and except the auxiliary for the water injection auxiliaries part and also the mold part. For the injection molding machine, there are three main modifications on the machine. The first one, the machine injection unit need to have a servo valve to precise control the material flow into the mold and also flow back to the barrel. That we need to have a really precise control and monitoring. And the second one is, of course, we need to have an electric interface between the injection molding machine and the fluid and injector system. This is Euromap 62. And the third one is the machine need to have a customized nozzle structure design, the R angle and also the nozzle diameter according to the mold. And this is the auxiliary equipment for the water injection. It's PME from Germany. Currently, Yizumi is working closely with this brand to design and develop the water injection technology for integrated turnkey solution for our customer. And the last one, I would like to talk about 3D printing, about Space 8. Space 8 is the Yizumi 3D machine model name. I would like to talk about the background, how Yizumi developed the 3D printing machine. Firstly, the Space 8 is developed by Yizumi Germany and IKV. IKV is an institution. The name is come from the German word. It stands for the Institute of Plastic Processing. We are using with the same similar school extrusion technology from Yizumi. That's why you can see Yizumi provide our know-how, technology, and experience from the injection molding machine. And IKV is really good at the material and material processing. And then we combine together, we research and develop a 3D printing machine called Space 8. And the Space 8, the 3D printing machine from Yizumi is majorly 4 parts. The first part is the injection side, the extrusion part. That is come from the Yizumi standard injection part from the injection molding machine. And the second part is about the controlling system. And the third part is about the robot, the 6-axis robot. And the fourth part is the drying system for the material. And this is how it works. The material will dry inside the dryer, and then we go through to the extrusion part, and the position placing system by the 6-axis robot. And the building platform we will offer to customer according to the product size. And then the advantage from Space 8, the major difference is the material. We can use the normal plastic than like PP, TPE, PC, or PP with glass fiber. We compare to the normally filament material, we have great advantage from the material cost. You can see around 1 to 8 euro pound to kg to compare to the filament is huge difference. And also high potential automation, because this Space 8 with 6-axis robot, you can design the product according to the product designs. And the scalability, because our Space 8 is combined with the extrusion parts. And also the building platform. You can, like injection molding machine, you can select the injection molding machine based on the clamping unit and also the injection unit. This is the same theory. And also the cost allocation, because why customer is intend to use 3D printing, because at the product's early design stage, everyone don't know whether the product is 100% fit the size and also meet customer requests. That's why we need to make a sample for the product to double check with our customer. And once the product size or dimension has confirmed, then you can go ahead for production scale for those products. And this one, I would like to show the actual production from Yizumi. This is the bicycle frame. The material is PA and glass fiber 30%. The production time is 100 minutes. Okay, now let's go about the application case. It's not only for the bicycle frame, but also for the structure parts, for the auto parts, automotive, and also the drone body has produced by our Space Age, and also some robot jigs. It can also produce by the Space Age. And the last part is about the direct compounding injection molding technology with DCIM. And about the traditional plastic process technology, you need to prepare the material from the material supplier according to the ingredient of the material. And then you transport to the material back to the factory and produce the product. And what the development of the new products and material, there's three major issues from the customer. And the first one is the development time. There were too many steps to prepare the raw material to the product. And the second is the product cost. And the material cost is too high and for mass production. And also uncertainty whether the material ingredient is 100% met customer requirement. Then there will uncertain effect on the product performance. Hence, we Yizumi develop DCIM technology. Then customer can combine the material online with production. Because we have some customer facing the problem whether the material ingredient is the 100% perfect. Like the PP material with glass fiber, PP material with degradable materials, and also some combination from different material. Then Yizumi developed this special injection unit. Then customer no need to change the mold, only need to change the injection unit side for the barrel and also the dosing system. And as you can see, the barrel can combine the material after dosing from this part is the material dosing model. Then you just need to type how much percentage you want to have from this material. Then the dosing system will measuring and measuring the weight and also the percentage before inject to transfer the material to the barrel. Then the barrel will plasticizing the material together. And the equipment of the DCIM technology is the measuring the material, that's as I say, and also the conveyor system can be equipped with 2 or more hopper according to the customer material receipt. And then it can use to measure and cover the plastic particles, powder, or even liquid material inside the barrel. And another specific is the screw size. The LD ratio will be longer than standard for mixing the material inside the barrel. And also we have a special drying-free barrels specific for PA material. As you know, PA with really strong pattern for absorbing the water. And then you can see there's a pipe above the barrel to absorb the water during the plastic siding stage and vacuum the water during the plasticizing. And this DCIM developed really efficiency for directly mix material and process the mold trial to animate the intermediate step like the prepare the material. And this is the actual application from Yizumi, the totally automated turnkey solution done by our Yizumi HPM. This wheel is with the metal insert robot, and the material is with glass fiber 30%. The cycle time is 72 per second. And here I would like to show you the video how it works automatically. From the hopper, the machine will calculate and measure the PP and gas fiber according to the setting from the HMI. Then the hopper will rating the material before transferring to the barrel side. And this is the virtual detect system for protecting the metal part embedded inside the mold. Okay. And apart from the technology that I just introduced, Yizumi also have advanced injection molding machine technology for foam pouring and direct foam pouring for long fiber direct injection molding inside the barrel. And also we Apple for PU reaction injection molding technology for PU injection. And also LSR, the liquid silicone injection molding machine. And if you have any question or any potential project, and I would like to hear from you and after this meeting or and during this stay in this hotel. And thank you for your time. And last but not least, I would like to invite you to our new factory inauguration in 7th of October in Namdapha. And it will be appreciated for your present to our great event in next month. Thank you so much, sir.
Thank you so much, Mr. Zhou. So I think we are already running out of time in this session, so I'll not take too long. And I know I'm standing between the lunch, so I'll make it quick, so you have to be with me for some more time. So I would like to just talk a bit about some futuristic plastics or technologies that we have also seen in our previous discussions and presentations. So the car that you see here is a BMW i8 car, and I got an opportunity to visit the machining company, it's called Hufschmidt in Germany, to visit their factory and see where it was made. So this is made with a thermoplastic carbon fiber composite material. The whole body is made with that. Very few cars were made like a concept car, and there was one car standing in their factory, so I got a chance to see that. So this, I'm displaying it here, and this makes more, I'm sorry, this makes more of a connection with what Mr. Sendil in the morning was telling us about the composites coming up big way in the automotive industry. This slide we have seen maybe thousands of times in our lives. So these are the two major categories of the plastics, thermoplastics. Oh, thank you. And the thermosets. So today I'm majorly talking about the thermoplastics, not the thermosets. And in any category of plastics, what we are all talking about today is the composites. So composites, as we know, is a combination of two materials. One is a fabric, and the other one is the matrix, which comes into the play together to give the properties together. So the properties of the two materials come together to give us an enhanced product, which is used in different industries like aerospace, automotive, oil and gas, medical, everywhere. And out of the two categories, I now funnel it down to the thermoplastic composites. So as we can see, thermoplastic composites or any composites have only two things. One is the matrix and the other one is the fiber. So fiber can be glass fiber, carbon fiber, or biofiber. I mean, we heard about the bioplastics in the morning. So it can be any fiber for that matter. And then matrix can be any polymer under the sun. So depending on the requirement of the application and the part, starting from PP up to peak, we can use any of the polymers as the matrix to make these composites. Now there can be different stages, or so here we see it's a semi-preg. This is the stage which we reach after the pre-preg. So pre-preg is the initial stage, and then we have the semi-preg when we talk about the composites. So I can just show you. So this is how a typical semi-preg would look like. This is, as you can see with the color, is with the carbon fiber, and this is with the glass fiber. So semi-preg is, So semi-preg is one layer of fabric which is impregnated with a polymer coating on it. So you can see it's flexible, and when you go for molding or making a composite part, you can use this also as it is. Or you can do it with the second stage, which is this, which is not that flexible, but still in a flexible state. How can I go back? Okay. Now if we press it further into the molding machine, then we have this is called an organo sheet. So if I make a sound on it, so it's just like sounding like a metal. So it's that sheet which has become rigid. So this has come out as a product out of this or this after molding. Now how is that done is what we see now. So the molding technologies, it can be isothermal or variothermal technology for making any composite. So these are the technologies used to make thermoplastic composites. In isothermal, as it states, it's isothermal, so the mold temperature is at one level, which is always below the TG, but it does not vary. But the sheet temperature changes. When I say sheet temperature, it means that this sheet in this form is heated up and down with infrared, and then quickly taken it into the mold. And this is where maybe Mr. Ramkumar's robot can come in and to placing it inside the mold, because it has to be done very quick. And that is, after that, the heating is done, cooling is done, and finally we get something like this. Or maybe if we place too many sheets one over the other, stack them up, depending on the thickness of our part, this is another sheet which we can get. So this is a thicker one made from maybe hundreds of these kind of organo sheets, semi-pregs. Or we can also, with the mold design, get some parts like this. So this is a part which is from orthopedic surgical instrument, you can say. So there's an arm here which goes inside the body, which is hammered from here inside the body whenever there is a fracture in the body, to insert some plates or screws in any of the traumas. So this part was conventionally made out of metal, and this was heavy. This was an obstruction when they were doing the X-ray. So with this composite, this is a PEEK composite with carbon fiber. With this, it does not obstruct the X-rays. X-rays can go through and through. The weight has gone down by 70%. So this is where the weight saving, what we spoke about in the morning, comes into play. So weight saving would any day increase your efficiency of any of the equipments. Now, why thermoplastics and not thermosets? So this is a very, very big question, because the pricing is far apart between the two categories of the plastics. So this is reformable. When I say reformable, means you press the sheets, the design does not come perfect, you take it out, put one more sheet on top, press it again, and it comes out. So that way it is reformable. Then shorter process time. Few of the advantages are there. High degree of automation possible. Mr. Ramkumar can play a role in that, as I mentioned. Storage at room temperature, which is a big advantage with thermoplastics, because with thermosets, you have to store the prepregs at minus 18 degrees. So storing them in your factory, you need that super cooled environment. Easy transportation, again, you need the refrigerated containers for thermosets, which is not required for thermoplastics. Recyclability, this is one point which we have been talking all the day. Recyclability, plastics, recyclable, bioplastics. So this is thermosets, once pressed into this form, can't do anything. But thermoplastics, yes, you can recycle them back. What are the disadvantages? Higher temperatures required. Yeah, that's true. So with thermoplastics, the minimum temperature which is required for molding even PP into this matrix is 200 degrees. So yeah, we need higher temperatures for thermoplastics. More complex machineries are required as compared to thermosets, yes. Selection of reinforcement is limited, yeah. So that's another disadvantage. Now we have to compare also with metals. When I say we have to replace metals with these composites, so yeah, we have to compare lower density. So lower density is directly proportional to saving the weight, maybe 70% in some cases. Higher impact resistance, tailor-made properties possible, because depending on the layers, depending on the number of layers, you can vary the mechanical properties. Selection of polymer is in your hand, PP or PPS or PPSU or PEEK. You can select any of the polymer depending on the properties required. Then the disadvantages, lower service temperatures, isotropic material behavior of steel. So when I say isotropic, I hope you all know that in steel, the isotropic behavior is there, that it does not disintegrate, because in polymers, the best properties you will get in the direction of the fabric. So if you stretch the fabric diagonally, then it's not that strong as compared to in this direction. But then we have a solution for this. So one sheet like this and one sheet like this diagonal would solve this issue. So there are challenges, but yeah, we can also find the solutions for them. Then, yeah, we are all learning about the composites. We are pretty new to this subject, and we will gradually know about it. That's why the knowledge is low, but yeah, we'll get to know about it. And that's all from my side. So, and also I would like to close the session at this point. And thank you so much, Mr. Ramkumar and Mr. Zhou, for your valuable inputs. And what I could sum it up is that what you both have mentioned is all taking us towards the Industry 4.0, and which is all about the prevention. So it's all about prevention and being smart. When I say being smart, is the integration of AI and IoT kind of things in the technologies that we have. So thank you so much. So looking at the clock, we can, for this session, we can only take 2 questions for the gentleman here.
Good afternoon. I am Venkat from Ranal Nissan. Question goes to Mr. Ramkumar. Explained about the USB also. Can you give some good explanation about the safety switches, LH and RH you told?
Safety?
Safety switches. In the same slide, it was the safety switches, left-hand drive and right-hand drive.
Yeah, to remove the teach box. To remove the teach box, will be holding safety switch. Like your hand will be holding left side and right side of the switches, by which you can remove the teach box away from your this one. Like you can detach it.
Okay, thank you. Thank you.
Yeah, there is a one more CE safety is there. Okay, this is a dual switch. This is used for the safety handling. Why this is switch is there? When there is a robot movement and there is a shock, the people tend to have a release the hand or grab the hand. So there is a safety switch. Once they release the hand or they grab the hand, the robot will stop at the same time.
Thank you, sir.
Yes, sir.
I'm Suresh from Bajaj, Nagpur.
Yes,
One of my client is doing a fast compression molding of PP caps and closures.
Okay, sir.
He's in the process of setting up a SACME unit as well. Right now he's doing injection molding of PP caps and closures. He wants to install robots. So is there any customized version available?
Yes, sir, we can provide, sir. We can provide. But at SACME, we have to see the output. SACME normally gives more output. Yeah. So for that, we need to find a solution. For injection molding application for the caps and closures, we have already given many solutions. Okay. We can provide.
Okay, thank you.
Thank you, sir. Okay.
Thank you so much, gentlemen, and thanks a lot to IPI for also inviting me for and giving me this opportunity. And I think now we can break for the lunch. Yeah? Yeah, okay. So now we can break for the lunch. Thank you so much.
I just have 2 announcements before.
Okay.
Okay. So we request all the delegates to visit our co-sponsors table behind. There is Ponnur Enterprises, channel partners of DuPont Multibase and with manufacturing of elastomers, and KPT Pipes, manufacturer of PPR pipes and fittings. Kyokuto Machinery for gravimetric feeders for compounding industries, and Mechatronics Industrial Automation in manufacturing technology. There's also a lucky draw from our numbers which has been given. So I'll be picking out it at the end of the day. So request all of you to stay till the end of the day for all the sessions. Now we'll have the mementos distributed for our speakers. I request Dr. Arun to distribute the memento to Mr. Ramkumar Wittmann. Mr. Yagdaman to distribute the memento to Mr. Wilman Zhou. present a memento to Mr. Nikhil Tiwari, our session chairman. I think he did a better job than me in coordinating the session.